Hi everyone, welcome to the 10th tutorial for your third module. Today we're going to talk about the magic wand and how to deploy a custom version of that on your Arduino platform. The magic wand is a very cool application that you can use to, basically interface and use the IMU on your device for a bunch of different applications. Students in the past have used it for a variety of projects, and it turns out to be really interesting when you actually end up using the IMU. So let's get to it. The deployment part is going to be the same as we did before. So we can go ahead to File, Examples, and TinyML 360, and then go up and open Magic Wand Sketch. This time the sketch is pretty simple, and we're going to go through why and how is the code set up. So first we're going to talk about what you do when you deploy a custom version of it. We have something which is already written for us, and we're going to see how it actually looks in the serial monitor and the serial plotter. We first select our boards and then go to serial monitor. So, okay, till now we know that the IMU has three different sensors in it. It has magnetometer, the accelerometer, and the gyroscope. All three of these contribute individually to tell the orientation of the object where the sensor is placed at in 3D space. Now we're going to take the device and then we're going to do some action with it. Okay, it's not clearly visible, but let's go for it. Okay, so now it should be visible. The whole concept of this particular deployment here is that the model is set up to detect different numbers. So 0 to 9, and we're going to draw those numbers in 3D space, and the model is going to detect those numbers and classify them based on what action that we're doing in space. It's pretty much like Harry Potter, where you cast a spell and you flick your wand in a particular way. So let's try to do something which is more legible. So if I do just like a 1, so you see that it's found 1 with a confidence of 98. The confidence scales are between minus 128 to 127, which is like 255 integers. This is like 8-bit representation in decimal format. I think we've talked about this in the past. So yeah, now we try to do a 2. Well, first 2, but okay, 2 again. Yeah, so now it's pretty much a 2, and it says that it's 2, but still has low confidence on this. So you can use these confidence values in your applications when you try to do your project or something, and try to tune it to a particular threshold. So I'll try a 3. Well, that was good. Yeah, so this is a 3 according to it by a score of 19, and like similarly you can do different kind of numbers, and because it's trained for all different sorts of them. Let's do 5. Again. One thing you'll notice is that the detection only starts after I've stopped moving the Arduino attached shield in the 3D space. Just to make everything easy, you can also remove the Arduino from the shield and tie it to an end of a pen or something so that it's much more convenient. We're going to remove that so that it's easier. So now we have the Arduino, just the Arduino, and well, so a 9 in some way, which kind of looks like a 9. So that's the whole concept of it. So we'll see how we can do a custom magic wand in this case. So let's close the serial monitor up and go to the code and do a quick code walkthrough. So we define raster width, raster height, raster channels. All of this is explained in the handouts that are provided to you because there's a dedicated instruction and it's also being discussed in the class. We go with a similar way. We define the tensor arena size. It's not too big because we just have the raw data and we need to process that raw data. And the way that we design the Magic Wand module and do the training on the Colab side of it. We define the null pointers and then we start with the setup. There's a fail-safe check to check if the IMU initialized or the Bluetooth is initialized or not. And then, yeah. So there's just like some bunch of Bluetooth stuff that needs to be taken care of. and then we get the model. The model is again in this file. It's the same thing. You copy the model into this, the model that you generate from the Google Colab, and then change the total size of the model. We take in the operators that we need for this particular deployment, and then initialize the microinterpreter, give the model input, and then invoke the tensors, get the output, and then run the simple, like the handle output command or the respond command on top of it. So yeah, that's pretty much it. What we need to change for custom magic wand is gonna be somewhere here. Yeah, so in the magic wand I know only, there's like an update section. So let's go and find that. It should be the top. These are all calculations for, translating. Oh, this is an IME provider. Sorry. Yeah. So we have update these variables to match the number of lists and gestures. So you can change these gestures in the same order that you record them um, in the Google Colab when you do all the training, and just change the label count to the number of them. So we have 10 numbers here. We change the label count to 10. That's all you need to do, and change the model data along with it. That's all for a custom magic wand, and you can use the same sketch for all your projects. And yeah, this is pretty much it. And let's meet in the next tutorial to see how to collect custom data sets for your magic wand application. Thank you so much.